Welcome to EACC Math Lesson number 14, using the distance and the midpoint formulas. Well, on this chalkboard we have all sorts of good math. For example, here's some calculus, that's called the integral, and that's going to find the area under the curve for a certain length or a certain interval of time. Here's some good old physics. And up here we have a right triangle, and you can almost see it here. They've got the Pythagorean theorem. And if you remember the Pythagorean theorem, we know that if we square this side and we add it to the square of that side, we get the square of the hypotenuse. Well, we're going to use this idea when we look at the distance formula. It's how the distance formula was developed. So let's go ahead and take a look at that. Okay. Here's the formula. The square root of the difference of the x-coordinate squared plus the difference of the y-coordinate squared. And it comes from this right here. I'm going to complete my right triangle. Okay? And good old Pythagorean theorem tells us that this distance squared, so in this case it's 3 squared, and this distance squared, which is 4, is equal to this distance squared. So 3 squared is 9, 4 squared is 16, and 9 plus 16 is 25, so this distance must be 5. Okay, so here's how the distance formula works. If you look at it, this is our x2 and this is our x sub 1. So that length of that side is the difference of the x-coordinates. And up here, this is our y sub 1 and our y sub 2, so this side has this length, the difference of the y-coordinates. And when we square those and we add them together, and then to solve for this side, I know I'm going to reverse that by taking the square root, and that's how our formula was developed. Okay, well, let's get this stuff off of here. And let's go ahead and use our formula then and find the length of this segment by using the formula. So we want the difference of the x-coordinates. Now it doesn't matter which x-coordinate or y-coordinate you start with because you're going to square it. So even if you get a negative result, it's going to make it positive. So I have 4 take away 1 quantity squared plus 6 take away 2 quantity squared. So this is my distance. So I have the square root. 4 take away 1 is 3. 3 squared is 9. 6 take away 2 is 4. 4 squared is 16. So we end up with the square root of 25. And as we saw earlier, that distance is 5. Okay. Second example, here we're going to find the length of this line segment. So using my distance formula, I know that this distance can be found by taking the square root of the x-coordinates, so 4 take away a negative 2 squared, plus the difference of the y-coordinates. So that's 3 take away 1 quantity squared. So under my radical, this double negative is going to make that plus 2. So that's 6. 6 squared is 36. 3 take away 1 is 2. 2 squared is 4. So I end up with 36 plus 4, which is the square root of 40. Now, 40 is not a perfect square. Numbers like 9, 16, 25, those are all perfect squares because we can take their square roots. For our purposes in this assignment, you can leave your answer like this if it's not a perfect square. In reality, this would simplify to 2 radical 10. But you don't need to take it that far for today. Later we'll learn how to do that. So here, just go ahead and leave your answer in radical form if it's not a perfect square. Okay. The next formula we want to look at is called the midpoint formula. And we use that when we want to find the middle of a line segment. Well, if you think of the word middle or average, think about two things if you want to find the average of, like two test scores. You simply add them together and divide by 2. Well, if you look at the formula, that's all they're doing. The midpoint's x-coordinate will be the average of the x-coordinates. So to find the midpoint of this segment, to find the x-coordinate, I'm going to take and add the two x-coordinates together, so I have -3 and 8, and divide that by 2. Same thing holds true for the y-coordinate of the midpoint. It's the average of the two y-coordinates of the endpoints. So I'm going to add the two y-coordinates together, so I have 5 plus -1, and again divide that by 2. That's going to give me my average. So my midpoint then, -3 plus 8 is 5, and so we have 5 over 2. 5 plus -1 is 4, so we have 4 over 2, which simplifies to 2. And I'm going to rewrite this 5 halves as 2 and 1/2, and leave the y-coordinate as 2. So my midpoint would have coordinates 2 1/2 and 2. All right, so here's another one. Let's find the midpoint here. Let's put our coordinates in. So on the left point, point A has coordinates -3, +4. And B has coordinates 2, +1. So to find our midpoint, we take the average of the x-coordinates, so I have -3 plus 2 over 2, and the average of the y-coordinates, so I have 4 plus 1 over 2. -3 plus 1 is a -1, and 4 plus 1 is 5. So again, I'm going to write this as -1/2 and +2.5. So that's the coordinates for our midpoint. All right. In summary then, we have our two formulas. This is our distance formula. Again, it's the square root of the difference of the x-coordinates squared plus the difference of the y-coordinates squared. That gives us the length of the line segment. And then this is our midpoint formula. And again, just think of it as average. To find the x-coordinate for the middle, just simply add the x-coordinates together, divide by 2. Find the y-coordinates, same thing. Add them together, divide by 2, and that'll give us the coordinates for our midpoint then. All right. Well, you've got some work to do. Go ahead, get started. And if you have any questions, please let me know. Thanks.